this video, we're going to look at calculating the x and y intercepts. So when we look at the x and y intercepts, these are where they actually cross the axes. So if I look over here, and let's say that here's a value, that is going to be a y-intercept because it crosses my y-axis. Now, for a y-intercept, your point is always going to be a 0, some number because you haven't gone anywhere left or right. When it's on the x-axis, it's an x-intercept, and that's going to be some number, 0, because you haven't gone up or down any. So whenever we have equations, what we're going to do to find the x-intercept is we plug 0 in for y and solve. For a y-intercept, we plug 0 in for x and we solve. So you're plugging 0 in for the opposite variable when you're trying to find the intercepts. So let's look at a couple of examples. When we have y minus x squared is equal to 9, and I want to find, we'll start with the x-intercept. So for the x-intercept, what I'm going to do is I will plug 0 in for my y. So I get that 0 minus x squared is equal to 9. So I get that negative x squared equals 9. Remember, we always want our variable to be positive, so I'm going to divide both sides by positive. Now then, if I look at this, and I have a square equal to a negative number, this is not possible. Because if you think about it, to solve this, I would have to take the square root of both sides, and taking the square root of a negative number gives me no real solution. So for the x-intercepts, we actually have none, which is highly possible. These could be the graphs that look like this, or they could look like this. In other words, they don't ever come across this x-axis. Now, where we go to solve for the y-intercept, we're going to have y minus 0 squared is equal to 9. So 0 squared is 0. So I get y is equal to 9. So my y-intercept is at the point 0, 9. So this one just has a single intercept. Let's look at a couple of others though, because some of them may have more than one intercept somewhere. Let's look at the equation of y is equal to x plus 2 squared minus 3. And so I want to first start out finding the x-intercept. Finding the x-intercept on this one is going to take us a little bit of challenge because I get 3 is equal to an x plus 2 squared minus 3. So I've got to solve, and so I'm going to add 3 to both sides. So I get 3 is equal to an x plus 2 squared. Now here's where we run into a little bit of problem. We got to get rid of the square, so I'm going to take the square root of both sides. When I take the square root of both sides, I have to take the plus or minus sign. The reason why is because if you think about it, if I take 3 squared, that gives me a positive 9. But if I take a negative 3 squared, it also gives me a positive 9. So it could be either positive or negative. So I'm going to have positive or negative square root of 3 is equal to x plus 2. And then I would subtract 2 from each side. So I would get a negative 2 plus or minus the square root of 3 is equal to x. These would be my x-intercepts. Not the best example because of the fact that we have square roots left. So let's look at one other example. Let's look at if we have y is equal to, we'll just say a negative x squared plus 7. Okay? And we want to first find our x-intercept. So that means I'm going to say, let's don't go with 7. Let's go with, we'll go with 16. That way it's a nice round number. So I'm going to have 0 is equal to a negative x squared plus 16. And I don't know why my pen is messing up. So I've got 0 is equal to negative x squared plus 16. I'm going to move my x squared to the other side. So I'm going to add x squared, mainly just because I want a positive x squared. And then what's going to happen is I'm going to take the square root of both sides. But again, I'm going to take plus or minus. Because if I have x, it could be a positive or a negative 4. Again, think about it. If I have 4 squared, that's going to give me 16. If I have negative 4 squared, it will also give me 16. So this is where I have 2 x-intercepts. I have one at positive 4, 0, and another at negative 4, 0. When I go to do the y-intercept, this is where we plug in a 0 for our x. So I get y is equal to 0 plus 16. So y is equal to 16. So I have a point at 0, 16. Now let's look if I want to plot these 3 points on my graph. We know that an x squared is a parabola. And I'm going to have a little bit of trouble because of the fact that my graph does not go all the way up to 16. But that's okay. I have a point at negative 4, 0. I have a point at 4, 0. And what this is doing is it's going way up here and then coming back down here as my parabola. This is why we have 2 x-intercepts and 1 y-intercept. Is because we have this parabola in which is facing downward because it was a negative x squared plus 16. The negative tells me that it's going to be facing down. And since my y-intercept is up here at the positive end, I have 2 x-intercepts. Now sometimes your x-intercepts may be different numbers. It could have been negative 3, positive 5. Okay? So it could be different values. It just depends upon your equation. Try to find some of the x and y intercepts based on the equations, and then let me know if you have questions.